Their intermolecular forces are higher, so they might exist as gases. So because
Okay. Hmm.
due to
So
the repulsion between these dipoles and also they must be getting
okay,
distant.
okay. So due to the weak intermolecular forces, yes or no? Weak intermolecular forces, molecular forces. So anything are the existing in the form of gas because of the intermolecular forces. Got it?
Yes, sir.
And even if you see, even if there is in case of the atomic orbital, this does not tell about the intermolecular forces, because what type of the bond are there here, that will decide the nature of this molecule, right? Nature of the
Yes.
what state they are. So this between the molecule, whatever the bond are coming between the molecule, that is called intermolecular forces. Okay. Now,
Yes.
tell me some characteristics of gases. Okay, then we will proceed. Characteristics of gases.
Sir, gases generally do not have a fixed shape, neither do they have a fixed volume.
Hmm.
So
Where you are
gases are.
disappearing, Sanoy? You are disappearing, not visible to me.
Sir, sir, I'm not visible. Sir, the camera is on only.
No, it is not. You are not visible to me. Hmm. Okay, okay.
Sir,
Leave it. No problem. So first point you only one point you told. Next, what other point you are saying?
sir can be compressible.
Highly compressible. Yes. Hmm. Okay, next.
So then,
Hmm.
sir, first highly compressible. So then no definite shape, definite volume. So
Uh-huh.
then they are having,
Hmm.
sir, they are having very weak intermolecular forces.
Hmm. Hmm.
Weak
Okay.
intermolecular forces.
Hmm.
Then,
Hmm. Next.
sir, they can undergo, sir, various all kinds of motion, sir, including that vibrational motion.
Hmm. Okay. Hmm. Okay.
So
What
gases,
about the density?
sir, they have very low density.
Why low density?
Sir, because the particles of gaseous particles are scattered in very large distances
Thank you.
owing to the weak
Why
intermolecular
they are
forces.
scattered very large distances?
Due to this weak intermolecular forces.
Okay. What about the melting point?
Sir,
Density.
melting point and boiling point is very low.
Melting and boiling point are why low?
Sir, that is because they are having less intermolecular forces. So to break these forces, very less energy is required.
Okay, okay, very good. So this all the things are happening. You see, you will find there is a one proper region is there. What is the region is there? Weak van der Waals forces. There are somewhere all the points are somewhere related with the intermolecular forces, isn't it? Highly
Yes.
compressible. How can you compress? Because the weak force are there. So it is keeping the
Sir, there
molecule
would be
far
less
away.
repulsion between the molecules.
So that is why what we can do, we can compress. Okay. No definite shape is there. If the molecules are randomized here and there, weak forces are there, so definitely there will not be any shape. Here the region behind the weak intermolecular forces. And what are the type of, now we are going for the weak intermolecular forces.
Sir, can
Here
you please
we,
bring the previous slide once again, sir? I was writing that one down.
that you only told now.
Low density. Sir, done.
Thank you very much. Weak intermolecular forces. Actually, Sanay, what is the problem? I like to teach you, okay, but I don't have time. A little bit time problem is there. Otherwise, I can give you as much time as you want. Okay, so timing is a big problem. Even though I want
Yes.
to teach you, timing is killing us. Okay.
Sir,
Hmm.
can you please give me, sir, the times when you would be free, sir? Then I can
I
adjust
am not free
accordingly.
now. That is the problem. I am not free. When I am not free, totally I am very busy. Okay. Totally, I'm very busy, very busy. See, there we are going to have the
Sir, but it
points.
has to be done, na, sir. Otherwise, how will it work? So it has to be done.
That is what doing now. What possible
Ah,
things are
yes.
there?
Yes.
Okay, the point number one. You tell the point number one, that is weak intermolecular forces. There are types of weak and intermolecular forces. So what are the weak intermolecular forces? If you are first one that trying, that is called London forces.
London
This
forces.
London forces. That is also, what is the other name of the London forces? Will you tell me?
So dispersion force.
Thank you very much. Dispersion forces. What is the strength in this case? London forces. It is the key point is
Strength.
hmm, force proportional to
Sir, they can
what?
work under short distances like around 500 picometers.
What is there? Inversely proportional to how much? R6. Inversely proportional to R power 6. Okay, this is what the force. Means very negligible force. Almost you can say that is negligible force. Then here is the dipole is there. One is dipole,
Dipole forces.
not dipole, induced dipole,
So that
induced
is given
dipole.
in the third number. So second number is dipole forces.
Dipole is stronger. I am trying to give you in the order of the
Order
strength.
of strongness. Yeah, dipole.
Okay, let us see. Dipole and dipole. Dipole is quite stronger. Here is the F proportional to 1 power 3. Okay, this is what the dipole is quite stronger in, they said the in solid state, in solid and liquid, in solid and in liquid. Okay, but if you are talking about, but in gas, the same. But in gas, the forces are the similar power. What is there? The force is dipole force proportional to depending on the R power 3. R is mass distance between the two dipoles. Suppose this is the plus minus and here is also plus minus. So this R3 is saying the separation, distance separation between the two molecule. Separation, this is the R. Okay. So how much it is depending? R power 3 means it is operating better. Next one you see,
Sir,
that
this
is
dipole is found by the polar covalent bonds. No?
polar covalent bond. Yes, HCl. Where, yeah, HCl. Where there is
Sir, H
the
will have partial minus, Cl will, no, Cl will have
uh,
partial minus, H will have partial plus.
yes, where the hydrogen bonding is not possible, there will exist the dipole. Okay. Next one you are saying that dipole induced dipole. Dipole, what is there? Induced dipole. Induced dipole. Dipole and what is there? Induced dipole. Next one is there, we have done ion dipole. Ion dipole. Yes or no? Ion dipole. One more is there. Ion induced dipole. Ion induced dipole. And last one more point is there. Ion induced dipole. And the last one is there. Hydrogen bonding. This is the special type, that is hydrogen bonding. So total how many type are there? That is total
6.
6 type are there. 6 type are there. Hey Asa, close the gate now. Hey Asa, close the gate. Okay. So what do you tell me one by one, because you already studied now. Tell me one by one.
Sir, I know, sir, sir, firstly, sir, I have studied it by myself only yesterday only. So
Uh-huh.
second is, sir, sir, I know only up to the dipole induced dipole, sir. After that, it is not given in NCERT.
But you are having the Akash book also now.
So that I have not read yet, right now. So
Uh-huh.
dipole induced dipole is, sir, this one, attractive forces operate between the polar molecules. They have the permanent dipole. One is having permanent dipole. Other should have not. Other should lack permanent dipole. And sir, this that the one molecule is having permanent dipole. So that dipole with induced dipole on the electrically neutral molecule also. Like the one which was lacking dipole, that will also start having dipole due to the other one. And sir, this dipole form will deform the electronic cloud of the neutral one, and thus the induced dipole is developed.
Okay.
Sir,
First
here
one is.
also the strength is same only as the London force. So they are also having 1 by R to the power 6 strength.
Mhm. So you
Sir,
are
they are also having a special point that if the molecule is more polarizable, then sir, then their attractive interaction strength will be increased.
okay. Okay. Here you see. First one, you little bit how the first one is there. No, London forces. London forces. Okay. How will you explain that London this you studied now?
Yes, sir.
How will you explain that it is starting? How can it operate?
Sir,
What will
firstly,
be?
we say that this one, that atoms and generally the molecules which are not having any polarity, sir,
Uh,
they should be electrically symmetrical. They have no dipole moment. Sir,
uh,
but some atoms or molecules that the dipole might suddenly come up momentarily, and
mm-hmm,
sir, suddenly come up momentarily, and like if we have two in close vicinity of each other, sir, then momentary electronic charge distribution can take place. And sir,
mm-hmm,
then one becomes unsymmetrical. The
mm-hmm,
charge cloud becomes not balanced. Like one will be having more electrons, other will be having less electrons. So
mm-hmm,
then they will be forming the instantaneous dipole, and so
mm-hmm,
this also distorts the electron density of the other atom or molecule, whatever it is there. So
mm-hmm,
because the one that is increasing in the first one is sourced from the second one only. And
mm-hmm,
so this temporary dipoles attract the temporary dipoles between two atoms, two molecules, or one atom or one molecule might attract each other.
mm-hmm.
And this same thing occurred in molecules also.
Okay, okay. Okay, thank you. So that is what correctly you are telling. Here you see now, this is the symmetrical atom. Yes, yeah, no. Symmetrical
Yes, sir.
distribution of electrons. If it is the symmetrical distribution, they will repel. In spite of attraction, they will repel. Yes, yeah, no. So what is going to happen in this case? When they are coming
Sir,
close.
one thing I did not understand.
Uh,
Sir, how you can call the second one symmetrical? Sir, because sir, if I draw a line suppose through here, sir,
hmm.
sir, like here, then sir, here it is 4 electron, but here it is only 3 only.
Not like that, yeah. Not like that. You are thinking different way. 2 to 4 to 6. 2 to 4 to 6. How much total to should be 2 to 4 to 6, 1, 7. You place one electron also here.
So
2
now
to
it is
4
okay.
to 6.
Now it is
Not like that. This is what they are saying. Shape is what? Shape is spherical, right? Shape is
yes.
spherical. So the electron will be what? They are the molecule having the octet now. Having octet. Having octet, right? That is why they will become the non-polar, na? If they are having
Yes, yes.
octet, so
So
this
then they will
atom
be polar.
non okay molecule that is atom will be what? That is there will not be
The atom will be
polarity.
non-polar. Sir, if they are not having the octet, then they will be polar, and then they will not be symmetrical.
They may take the electron or give the electron. If they are not having octet, what they will do? They will try to accept the electron or they will try to lose the electron. Now, you see here what is happening in this case. What is when they are going to approach together in any way, they are going to approach. So, what will happen? Electron density of this will come this side and this will come this side. So, that is here is the positive charge is there. This is the positive charge. All the electron are going one side. This all the electron will go one side. Here also the electron are also going one side. But what the possibilities are there? Okay, the possibilities are there. This will become the on a temporary negative and this side temporary positive, and this nucleus will also be little bit the shifting because shape also going to be distorted. Nucleus is coming to be the one end, this one. So what this is going to attract the electron cloud of this one. Yes, yeah, no. This is the partial
Yes.
positive. Here is partial negative. And next molecule, if you are making the another one, another, so what will happen? The same way now, same way this will be the partial negative,
So here
partial.
also it will partial negative, partial positive.
So this is here that is the interaction is started between the nucleus of one atom with the electron density of another atom. So this is the concept of London forces. Okay. And it is the very weak London forces. If you are drawing the characters, how much energy of their energy of the London forces? Energy.
Sir, I don't know about the energy, sir, but they work in very less distance, about 500 picometer.
So dissociation energy is there 1 to 10 kilojoule per mole. 1 to 10. For breaking 1 mole of bond, 1 mole of London force, 1 mole you must be knowing 6.02
Yes, sir.
to 10 power 23. This many bond, if you want to break this many bond, only minimum energy required 1 to 10 kilojoule per mole. Getting my point?
Yes. I get it.
Next point is there. After energy, second point is there. With size, with increase in size, what will be happening? With increase in size. With increase in size. Tell me the answer. With increase in size, this force will increase or decrease?
The decrease.
Increases. With increase in size, it increases, not decreases. It increases. Okay. In bracket, all intermolecular forces increases. Intermolecular forces increases. Intermolecular forces increases.
Sir, then what about this one, sir? Like, it is given the forces are important only at short distances. But sir, if the atom is getting bigger, sir, then the distance will also get bigger. Na, sir, how they will be more effective?
No, they say that the van der Waals forces, van der Waals forces, van der Waals forces, proportional to mass, not okay. This increases with site molecular mass, no, molecular mass. Okay, and molecular mass proportional to, sometime proportional to size also. Okay, molecular size. Anything else is molecular size. Proportional to surface area. Surface. Okay. Surface area, if you don't want to, no need to write, but it is like that. Proportional to number of electron also. Number of electron. Whatever the van der Waals forces are there, van der Waals forces, they all are the increasing with the molecular mass. If the molecular mass are high, means there will be the forces will be the stronger. Intermolecular forces will be going to be the stronger force of attraction. Okay. And you are saying that is what is said, that is if your size increases, then what you said?
So size increases, so then the distance will also increase. So then
There's the distance, that is intermolecular, atomic distance are increasing, na, radii increasing, na. Intermolecular distance are not increasing, na.
yes, sir, I understand.
This is the something different what we are studying. See, which distance they are talking about. Suppose this is the dipole, okay, H and Cl. So this is H plus is there and Cl minus is there. Similarly, HCl is there. So what they are talking about, and then you go HBr. Okay, HBr. Here is HF. HF. I'm explaining like that. Here is also HF. So here the strong force are there. Na, is here is not that much of a strong force. They exist in the gaseous state. GASEOUS, gases. The HF is totally gas. HCl is also kind of the gas only, kind of gas only. HBr, this is found in the liquid state. Okay, liquid. But so on what basis you are going to explain that they are the liquid state? HI sometimes found in the solid state also. On what basis will you say? Because of these forces now, intermolecular forces. Because of intermolecular forces, when you are going down, so what is happening? They are the, when you move down the group, van der Waals forces increases because of the molecular mass increases, so that the force of attraction high and molecule become gas to liquid and solid. Is it okay?
Yes, sir.
Today, one question I'm giving you, you study factor affecting. Factors affecting. Okay, this you study next class. I will ask you factor affecting intermolecular forces. Intermolecular forces. Getting my point? That is first factor you are going to find this one size. Atomic mass and size. This all things. Okay, got it now.
Yes, sir.
Okay.
Sir,
Now
I will find out the answer and I will send you, sir, once I found.
Thank you very much. Thank you. Thank you. Okay. So no. Next one is there, we are having dipole. This one you are telling, na? Dipole interaction. So this you can explain now. Dipole interaction. Give me dipole. See,
That
you can
some molecules are
HF. Okay, you cannot give. HF you cannot give. Okay, H2O also you cannot give. Although they are the very polar. Okay, and one more NH3 also you cannot give. NH3. Why?
So what is the problem in these ones?
Because they form the hydrogen bonding, more stronger hydrogen bonding, H bonding.
So then hydrogen bond is more stable.
This is the stronger now. Hydrogen bonding is stronger. Hydrogen bonding is stronger because of the
And sir, this
electronegativity
is the
problem.
normal tendency that when they will be having a stronger bond, they can form certain, they will form that only.
Yeah. But here dipole, if somebody is asking what type of the bonding is there, suppose we are talking about HBr, okay, H2S, okay, HI, okay,
Sir,
PH3.
like with hydrogen, any element other than nitrogen, oxygen, and fluorine will form the dipole interaction only. So because
Yeah.
hydrogen bonding is not possible for elements other than fluorine, oxygen, and nitrogen.
Here the size are more, so there is this one is not, hydrogen bonding is not possible.
So then
Only
less electronegative also.
less electronegative also. So there will be the dipole interaction. If you talk about the dipole interaction, so there is the explanation not required now. You already know now. See, HCl is there, then again HCl is there, then again HCl is there. So what is there? Plus, minus, plus, minus, plus, and minus. So what will there? You know very well opposite charges attract each other. So if they
Yes,
are
sir.
attracting each other, what will happen? Plus, minus, there will be attraction. Plus. So this is what is that is called this type of forces. What dipole? Because they are the
So
dipole.
this is always found. This is always found between the molecules which are having permanent dipole.
Yeah.
Like this aims is the partial charges, and then the partial positive and partial negative will attract each other.
Yeah. Very good. So what are they are having the some characters? Okay. The point number one is there. It is stronger than. It is stronger than London forces. Is stronger than London forces. Actually, all the forces are the stronger than London forces. Okay.
The
London
London force is
force,
the weakest one.
that is the weakest one. And second one in solid state, what we wrote that it in solid state if the there. So these forces are stronger. And what is that is with the distance it is R3. But in the gas state it is almost that is the similar to the London forces. It will act like that 1 by R power 6. Okay. This is the experimental data. Okay. That we cannot say anything about that. Okay. So this is things something you need to memorize. Getting my point?
Yes, sir.
Next one you see dipole induced. You explain this one dipole induced with the example. Dipole induced dipole.
Sir,
Yes.
sir, one atom will be this one, sir. Another atom will be this one. So here, I'm giving the example. So like this will be like one will be having the dipole. One will be having the dipole. So the other will be neutral. So then when they come closer, so then this one will continue to have its dipole. But sir, due to the influence from this, so let this be A and this be B. So due to the influence from A to B, sir, B will also turn into a dipole. So B will also turn into a dipole. So now this one is a induced dipole. So because due to the induction from this one, this has formed. So now once it is formed a dipole, so once it is formed a dipole, so 1 second, just. So once it is formed a dipole, so then there will be normal attraction between this one.
Okay. Correct. Can you give me the example of this?
No, sir. Example, I don't know for this one.
Example you can see. Any example you can see that is like you can take the HCl
It's
and you can take the argon. Okay. or HCl, you can say the helium, or any other dipole, anything you can take. Now, suppose you are taking H2S, and that is you can take argon, or any noble gases you can mix in this one. Okay, noble gases or hydrogen, anything you can mix. This they will be mixable to this in this one.
Sir,
Getting?
H2S plus Ar. So,
Ah,
like, because noble gases will be neutral, so sir, this HCl will have a permanent dipole, and so they will induce the dipole on Ar.
yes, 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 yes. Okay. So these things you know very well. One second, Sanay, one text I need to do. 1 second. Okay. What are the characters? If I will write the characters, Sanay, what the character will give? What will be the strength? What the strength can you guess?
The
This will be
strength is
more.
same as rotor forces 1 by R to the power 6.
Okay, very good. So one is power R power 6 is there. Force is equal to force proportional to 1 power R6. So this is what the dipole. Next one more we are having. What is there? That is the ion dipole. So ion dipole, it is also permanent. This is the permanent. Because the ion is the permanent, like sodium ion is there. Sodium. Sodium ion can be dissolved into the water. What it is going to do? So water, it will be like that one. So this is the partial negative and partial positive, partial negative. Here is partial positive. So what is going to have here? This is going to attract. Can it attract? This positive charge can attract the oxygen. Yes or no?
Yes, sir.
So like that, this is the negative, positive, this is the positive. It is also going to attract the sodium. Are you be able to understand?
Yes, sir.
Okay. Now, one more point is there. What is the point that you need to tell? Here, this is the attraction are there. What will happen if I will have Cl and H2O? What type of interaction will be there? Draw the diagram. What type of interaction will be
Cl
there?
and H2O. Yes, sir.
Are you making the diagram?
Sir, is it not visible, sir? I'm making
Yeah,
on
yeah,
the
yeah, yeah.
downside.
But here it will be the negative. Okay, correct. Okay, correct. Okay, correct only. Hmm. That is negative charge will be surrounded by here. How you will get the covalent bond here?
Sir, then how will it
Like
be
that,
formed?
like see. Okay, wait. I'm doing. Okay, almost that is correct only. Almost 99% you did the correct one. Suppose it is the negative charge. Any negative charge, I am taking the Cl as a negative charge. So the Cl will attract the positive side of the any other things, na? So this will. Okay. Another if you are making this hydrogen, this will attract. Another you are taking hydrogen, this will attract. Okay. Here is the hydrogen, this will attract. Here see oxygen was attracting, but here the what is attracting? That is partial
Hydrogen.
positive. Why hydrogen is attracting then?
Because
What
it
the
is partial positive and Cl is negative.
yeah. So this is what the concept. Now, so these are there. Any other things are there?
No,
Any
sir.
other point are there?
Sir, please hold this slide for 1 minute, sir. I will note down this one.
Okay, no problem. Hmm. In our school, that is what the exam started now yesterday only.
Yes, sir.
So today the 12th students are also supposed to come. because when the exam is there, they are not coming. Now they are planning to come. When to teach to them, I don't know. This shortage of time.
So just 1 minute, sir. I won't take much time. I will directly
Yeah,
write this
no
down.
problem here. Mhm.
So done.
Okay, I'm giving you one question. Wait. Let me teach first. What is there else is there? Ion dipole, ion disperse,
Ion induced dipole.
ion induced dipole. This also you will be able to understand. Ion induced dipole. Will
Sir,
you be
same way now.
same way? That is sodium is there. Any of the noble gases you can mix, like helium you are mixing anything.
Sir, there only the only change we are having is that there we had the molecules as dipoles. Here we are having individual ions. That is the change.
Yeah. And hydrogen bonding, I already teach you now. Hydrogen bonding. Yes,
Sir,
yeah, no.
that was in chapter 4 only.
So that's
Like
so,
chemical bonding.
yeah. Similar. That is similar now. Yes, no. Yes, yeah, no. Ah. Now, the point to which hydrogen bonding I am giving you. Otherwise, what you do, you give me time. I am sharing another link because it is going to disconnect. Then the problem will not be over. Okay.
Yes, sir. Yes.
Mhm.